everyone. I'm Luchen Tan from a company named RSVP.ai. Today I'm going to present a paper which is describing a deployed system developed for JD.com. And we are trying to detect a problem called customer complaint escalation. And we are using RNN with some manually extracted features. So let me first introduce RSVP.ai. We are a Canadian-based startup company. So we are located in Waterloo, and then we have other offices in China. And what we do here is we try to understand human language, understand all the natural language, and we build up different systems, try to teach the machine to learn and then to talk like a human being. And the company that we are working with at the time of the project is called JD.com. And JD.com is one of the largest e-commerce company in China. And we have a number here which says as the first quarter of 2018, the active user on the platform is over 300 million. So we are talking about the problem called customer complaint escalation. So we look at the problem first, start from example of the conversation between a customer service agent and a customer. So here, the agent started his conversation by a very common welcome sentence. Say, for example, I am agent number 1234 and I would like to help you. But actually, the customer has already had some emotion before starting the conversation, and he has getting annoyed by some problem. So he wished to solve the problem immediately. But what the customer agent did is he didn't solve the problem immediately, but he's trying to go through some common regular process. So the customer getting really annoyed. And then the customer started to threaten the customer service agent that I would like to protect my right, or like I would like to file to a higher level institution. I would like to file to the government and talk about some special issues. And then I would like to post my experience online, and I would like to talk to other customers. So this is a problem that comes more frequently nowadays. So all customers nowadays are expecting a high quality online shopping experience. Whenever during the shopping experience, the customer feels any dissatisfied on any aspect of his purchase, or he feels that his or her right getting violated during the whole experience, they would like to express their complaint. And the existence of the online chatting customer service and also the call center makes this expression more easier. So the customer would like to go online to talk with the customer agent, or would give a call to the call center, express this complaint. And then usually after they express this, they would like their problem getting solved immediately. But most of the time, the customer service agents are not doing a really great job. They don't solve the problem immediately. So some of the customers would like to go to a higher level authority, for example, the government, and then they would like to express this complaint to go to the higher level, which we call the customer complaint escalation. So we group these kind of customer into a special group. We call them tough to please customers. And this kind of customer, so as what I said, first they would like to connect to the company's representatives. So they contact the agents first. So as according to the statistics, about 75% of this kind of tough to please customers, they would like to talk with the agents online through chatting. And then about 25% of these kind of tough to please customers, they would like to give a call to the call center, or they will talk to the customer agents face to face. And then after that, they will go to the higher level for example, the CPB. And then we also counted the number that about 70% of these kind of customers connect to the agents first and then go to the higher level. And also there are about 30% of these tough to please customers, they didn't talk with the company's representatives. They go directly into the CPB. So what we are doing here is we are trying to detect these kind of special customers, detect those customers that has high risk of going into the higher level to express their complaints. And then what we can do is we can try to go through their dialogue history between the customer agent and the customer, and then try to detect from the 70%. So based on the numbers that given from JD.com, we know that there are more than 300 complaint customers every day to the highest level CPB in China. And then we know that the problem keeps going on. This kind of bad customer service experience will cause a huge damage to the company. Not only about the brand loyalty, but also about like the reputation online. So they really take this problem as a serious problem. But this is also a really hard problem because we are not we are not only detecting the sentiment of the customers, but we are actually detecting the intent of the customer, the real intent. Are they really going to go to express their complaint? So this is very different. Many customers, they say very bad words, they express their angry when they are communicating with the agent, but they are just threatening. They do not go to the higher level. So the ratio that between the real complaint customer and the overall customer is really, really a small number. And also why we say it's very important for a real-time detecting system, because we also counted that how many customers go to the higher level within a day after communicated with the customer agent. And also how many customers waited until about a week, about a month, and even longer time. So about half of the customers, after communicate with the agent or the representatives of the company, they will directly go to CPB to complain. And then about another 40% of the customers, they wait from 1 day to a week, so which means they wait within a week. And then another about 10%, they wait a month, and then about 4% of the customers wait more than a month. So we treat it as an online classification problem, and then we only do it over dialogues because we know that 75% of this kind of customers go through the online chatting, and also this is a very good starting point. So we can first solve the online chatting problem and then go into the phone calls, the call centers. So the numbers here that the real complaint customer over the overall customer number is lower than 0.01%, which means this is a very rare case. And then how to detect the real intent of these kind of customers. So we use a model. What kind of model should we use? So this is a NLP problem. So we started from very simple models. So we start from TF-IDF vectors. So if you know what is TF-IDF, it is something that can give you a number for each individual term and then tells you basically the importance of this term. So we start from using TF-IDF vectors, and then we go through into a even higher level abstract of the features. We do some manually engineered features, and then of course we tried neural networks. So we started our experiments from a published network. So this is called Hierarchical Attention Network. So this is published in NACO 2016. And then, so this network has two different layers. So it extracts different information from the word level and the sentence level. So this is something that works, but when we tried our experiments, we figured out that the network here is too complicated and it didn't give more benefit to the real problem. So we simplified the model here. And then here is our model. So we take a fixed window size of the incoming dialog stream, and then we take the agent sentences with the customer sentences as the input of the model. We use bidirectional LSTM to extract some information between the words and the sentences, and then we also used attention mechanism. So this is a flat, we call it flat attention network, and then this is a baseline model of our experiment. So what we added in here is we added in some more features that we already proved that they worked. For example, like the TF-IDF vectors, we know that for many other NLP tasks, these are very good features. So we add them into our FNN, or we said flat attention network. And we also add in some other external features. So these external features are also like commonly used NLP features. For example, the emotion or emojis in the sentences, and then the use of different punctuations, special punctuations, for example, like question marks, and then how long is the sentence, how many words is used by the agent or by the customer. And also we collected two special dictionaries. These two special dictionaries are the common words that are used by the customers who going into the complaint process. So we counted the uses of these special terms. And then we combined everything together into the FAN full model. And then connect everything into a softmax layer, and then go to the classification. So this is our evaluation. We evaluated the model by using recall. So the recall is defined as the number of detected complaint customers in top K. So K here means that, for example, the company has a specialist pool that we report to this specialist pool, and then this specialist will try to connect to the complex cases of these customers and then try to solve their problems more efficiently. So the K depends on the size of the pool. And then we divide it by the number of customer complaints on that day. So we compare the different models. So we have some different baselines. The first baselines are the logistic regression or the like GBM, the tree algorithm, on some special vocabularies. And then we also tried some simple neural networks, for example, FastTaxi and LSTM. And then this is our FAN base model. So it beats all the baseline models. And also when we add into the TF-IDF, it gets even higher, boosted the performance. And the full model, which means we add into TF-IDF vectors and also the external features. So it is the best model that we tested. Also, because we noticed that this is a very rare case, which means we need to carefully select the size of the negative examples. For example, we take the complaint as a positive examples, and then we tested the different sizes of negative examples. So we figure out that until a certain race, there's no benefit to add into more negative examples. So we tested the model on history data. So it performs as about like 20 to 30% of the recall. And we also tested on a deployed system. So this is an online result, which means our model performed almost the same performance on the online. So here are some lessons we learned. So we always start from some simple models. We don't need to go into the most complex model. And then usually in some real online systems, the complex models, it means that it takes more time for training. It takes more time for the prediction. And usually it doesn't work for your online system. And then we don't always need to start over. We have some good features. We have some existing solutions. We can add into, we use those solutions. We add into our fancy models. And then the third one is, if your NM model cannot provide enough capability, you can always add into some manually extracted features. So yeah, this is the thing that I want to share today.
We have around 5 minutes. Oh no, we're over, right? That's 5 minutes for question. 5 minutes. But yeah. Okay, let's have 5 minutes for any questions. I can get the questions started. So first, you showed us a few models. It seemed that when you added TF-IDF, there was a significant boost. Now, did the other models that weren't yours use TF-IDF as well, or?
So the thing that is the TF-IDF is just used for taking some for some special vocabularies, and all the other models, I didn't have enough time to mention that they are actually exactly using these kind of features.
Great, beautiful. Then the comparison is really fair. If they've been using TF-IDF.
Yeah, they are using it, and we are using them.
Okay, beautiful. Any questions from the audience? Okay, I'll ask another one. So there's another one. So you had it was recall at 5,000, was it?
Yeah, 5,000.
5,000. How did you come? Because you didn't show any F measures. It seems that it's not standard to show it, but we also do want to know how good or bad the model is performing on precision.
Precision, yes. So this is a very special case. So the company, they don't really care about the precision. So you can imagine that. So they want to cover as many cases as possible. So the recall is the real thing that they really care. They want to cover as many cases, so they can waste their time to treat some negative cases, but they also solve the customer problems. So they don't really care about the precision. So that's why we only use recall.
I see. Okay. Beautiful. At any point, does it get infeasible? Like 5,000 seems to be a feasible one. They're like.
Yeah. So this depends on the pool of the special customer service. So there is a special team that we report to this team, and then this 5,000 person can call individual customers to solve their problems. So they have this capability of 5,000. That's why we set it as 5,000.
Beautiful. Any questions from the audience? I'll ask one more question, and maybe if there's an ending after, we can go home. So the next one, did you have? Could you show me the architecture, please? If you still have them on, otherwise.
Yeah.
Oh, yeah. Interesting.
Yeah, I should have a picture of the full view. There.
Alright. So, could you tell me, so there are dotted lines coming from W attention. Could you explain about that and how all the attention mechanisms kind of work together to get the encoded dotted representation?
So this is a very typical attention mechanism. So the whole network is just the by-LSTM added into the traditional attention mechanism. So there's nothing special here. So the dot here is just showing that. So this is actually the attention weights.
Okay, so let's. So what's W a subscore? So that's the weights of your attention, right?
Yes.
Where does it come from? That's not connected.
From the training, so we do back propagation and then update those weights.
Okay, gotcha. All right, beautiful. Any other questions? No, well, let's thank the speaker. Thank you very much.
Thank you.
It's a 20-minute break, I think. Okay. Or 15 at this point. Thank you so much.
Okay, we have a 15-minute break. Let's be here at 3.
We have to the speakers.